In this video, we will practice graphing some trigonometric functions like tangent, sine, cosine, cotangent, cosecant. Let's start off with the basics. Let's start off with cosine. Now, whenever you have a b value and a phase shift, you need to factor the b value outside of parentheses. So I'm going to rewrite this equation, starting with this part right here. I'm going to pull out the 3. Okay, this 3 right here, I'm pulling it out right here. That's going to leave behind x plus pi. Okay, so that was a little simple. Alright, just pulled out the GCF in this case. And so now all of that is inside of this function. So I still have the cosine and my negative 3 out there. And the minus 2. Alright, but it allows me to see the phase shift for what it is. Now, the amplitude is going to come from this negative 3. Of course, amplitude is always positive, so I'm going to put positive 3 for my amplitude. Now, the period. The period is going to be the normal period divided by the b value. And the b value here is 3. Alright, so that's it. So the period is just going to be 2 pi over 3. Alright, the phase shift is going to come from this h value right here, but it's going to be the opposite sign. So the phase shift will be negative pi, which is of course to the left. The vertical shift is the k value. So there's a vertical shift of negative 2, which of course means down 2. Okay, so that should be plenty enough information for us to go ahead and sketch this graph. Okay, so here will be my x-axis right here. Now, whenever there is a phase shift, that's where I begin my graph. So we have a phase shift of negative pi. So I'm going to go ahead and mark negative pi right here, and that is going to be my first value. Okay, negative pi. Okay, we always need 5 values for each period, so that's going to be my first one. Now for my other values, I'm going to count 4 spaces to the right. So here I go. 1, 2, 3, 4. So this will give me 1 full period. Now as I move to the right, what I need to do is add a quarter of a period. Alright, see these are 4 spaces, so each one of these represents 1/4 of the period. So that's what I need to do. Now the period is 2 pi over 3. So the quarter period is going to be 1/4 of 2 pi over 3. Okay, so my quarter period is going to be 2 pi over 12. So which means that my quarter period is going to be pi over 6. So if I want to add a quarter period, I need to take this phase shift and I need to add pi over 6 to it. Okay, now of course to add I need like denominators, so I am going to modify, just move this out of the way. I'm going to modify this to make like denominators, so I'm going to have a denominator of 6 and a numerator of 6, so that's going to make this negative 6 pi over 6. Alright, negative 6 pi over 6 is the same thing as just negative pi. So that's what I'm going to do. So I'm going to add my quarter period. I'm going to add pi over 6. So if I take negative 6 pi over 6 and I add 1 pi over 6, that's going to make negative 5 pi over 6. And if I add another pi over 6, that's going to make negative 4 pi over 6. And if I add again, I'm going to get negative 3 pi over 6. And if I add again, I'm going to get negative 2 pi over 6. Okay, now I've left myself space here. Just clean this up a little bit. I've left myself space to reduce the ones that need to reduce. Negative 5 pi over 6 does not reduce. But negative 4 pi over 6 reduces to negative 2 pi over 3. This one reduces to negative pi over 2. And this one reduces to negative pi over 3. So these are the 5 values that I'm going to use. Now, having said that, I need to know where the y-axis is. So the y-axis is always at 0. None of these are 0. And in fact, they're all negative. So what I need to do is I need to keep going until I get to a positive value. So that will show me where the y-axis is. So if I kept on adding pi over 6 like I was doing before, the next one, so here, let me put some more marks on here. Okay, just a couple more marks should do it. So if I kept adding, my next one would be negative 1 pi over 6. But then my next one would be 0 pi over 6, which of course is just 0. So see what's happening? Negative 6, negative 5, negative 4, negative 3, negative 2, negative 1, and 0. So I'm going to go ahead and just record these. So I've got negative, wow, okay, that's really light. Let me not do that. That's too light for you to see. How about this one? Negative pi over 6 and 0. Because this is 0, I'm just going to go ahead and put the y-axis right here. Alright, now I put this negative pi over 6 in light gray so you wouldn't confuse it with these other points. These 5 values that I've shown here in purple, these are the 5 positions of the critical points I will use for my graph. Negative pi over 6 is not one of the 5 critical values I will use, so I made it a lighter color. Alright, so this is going to be my y-axis right here because this is right at 0. Now I need my y-axis to mark off my vertical shift and to record my amplitude. Okay, so keeping that in mind, so I have a vertical shift of negative 2. So I'm going to count my way down. So this is negative 1 and negative 2. Okay, so this is negative, whoops, I said it right, but then I started numbering it wrong. So this is negative 1 and this is negative 2. Now negative 2 is going to be my brand new midline. So I'm going to go ahead and let that be a dotted line going across like this. Okay, my brand new midline. Okay, now it would also be helpful to put some marks indicating my amplitude. 3 above this and 3 below this. So if I go 3 below here, okay, I'm trying to keep it evenly spaced out. 1, 2, 3. So of course this would be negative 3, negative 4, and negative 5. So my low points will hit right here at this negative 5. Okay, so I'm going to go ahead and just mark that off as well. Okay, it will just help me make a more accurate graph later. Now if I went up 3, okay, that's 1, 2, and 3 would be right here at positive 1. So I'm going to go ahead and put some marks floating right here at positive 1. Okay, so that tells me that my higher points will be at this line. Okay, so now I've got my midline, my highs, and my lows, and I've got my 5 x values. So I am ready to go. Okay, so I know that the cosine function, well, when it's a positive a value, my cosine function starts off at its highest value, and then it goes down like a bucket. But because it's a negative a value, it's going to be reflected over the x-axis here, well, and thus reflected over the midline. So my first value of cosine is actually going to start at its lowest point, all right, lining up here with my negative pi. And then it will go to the midline, and then at this value, it should be at its highest point, and then it should fall back to the midline at this critical value, and then it will fall back to its lowest point again at this value. Okay, so my cosine is going to look like this. And there is my graph of the cosine function. And that's it for number 16. Alright, now let's move on to number 17. So let's go ahead and rewrite the equation like you do when you see a b value and a phase shift trying to happen. You need to take that b value and move it outside the parentheses. Okay, so I'm going to have x minus something. Now, to see the value that goes here, I need to divide this by this. So I need to take pi over 12, and I need to divide by 1/4. Well, that's pi over 12 times 4, because you multiply by the reciprocal. So that's 4 pi over 12. This reduces down to pi over 3. So this is going to be x minus pi over 3 right here. Okay, so that's going to give me the rest of this. So I still have tangent like this. So I can now safely determine the period. The normal period for tangent is pi. So we know that period is always the normal period divided by the b value. So it's going to be the normal period divided by 1/4. So that means the period is going to be pi times 4. Alright, you multiply by the reciprocal. So that means the period is 4 pi. Okay, great. Period is 4 pi. Now the phase shift is going to be this right here, the h value, pi over 3. Now this is pi over 3 to the right. Alright, it's the opposite sign from the equation. So it's going to be positive pi over 3. It is to the right. Now tangent has asymptotes. So we'll have to write an equation for all of the asymptotes right there. But we will do that at the end after we graph. So, tangent. Hopefully you have memorized at this point that this is what tangent looks like. Imagine that we have one period of tangent. Okay, so I'm just going to put 5 marks here. 1, 2, 3, 4, 5. So this could be, this is not necessarily the x-axis, but this is the midline. So I want you to memorize that tangent begins and therefore ends its period on the midline. And right in the middle, there is an asymptote. Okay, you just really need to memorize that. Tangent begins and ends on the midline. And then tangent is an increasing function. So from here it's going to rise towards the midline, and here it's going to fall. Well, you know what? I just always want to think of it as rising. So I'm going to start low and rise towards this point. So this is what one period of the tangent function will look like. Now, I don't know if we will get to cotangent, but I always like to sort of mention them together. Compare and contrast, if you will. So by contrast, the cotangent function, instead of beginning and ending with a point, cotangent begins and ends with an asymptote. So if this were a cotangent, it would start with an asymptote and end with an asymptote, and then there'd be a point in the middle right at the midline. So this is what cotangent would look like. Okay, so here is my x-axis. There is a phase shift of pi over 3 to the right, so I'm going to start at the phase shift like I always do. Now, we always graph two periods of tangent and cotangent. So instead of just putting my mark all the way over here on the left, I will go ahead and put my first mark in the middle. So I can put one period to the right and another period to the left. Okay, and so my first mark will be called pi over 3 because that is the phase shift. So I'm going to put 4 marks going to the right. So it'll be like this. Okay, 1, 2, 3, 4. And I will go ahead and put 4 marks going to the left as well. So 1, 2, 3, 4. I need to know the value of all of these marks. So what am I going to do? Quarter period, people. That's what I'm going to do. The period, well, this is going to be a little extra simple. The period is 4 pi. So that means a quarter period is 4 pi divided by 4, which is just going to be pi. So a quarter of a period is going to be pi. That means I need to take this pi over 3 and I need to add pi in order to get the next value and the next value and the next value. I'm going to add pi all the time. Well, if I'm going to add pi, though, I need like denominators. So this is sort of like having pi over 1. Okay. So to make it like denominators, I really need to multiply by 3 in the numerator and the denominator. Okay, so my quarter period is really like having 3 pi over 3. So I'm going to start with pi over 3. Okay, but I'm going to add 3 pi over 3 to it. So if I do that, I'm going to have, so this is sort of like having 1 pi over 3. So if I had 3 pi over 3, that would be 4 pi over 3. And if I had another 3 pi over 3, that would be 7 pi over 3. And if I added another 3 pi over 3, that would be 10 pi over 3. And if I added another 3 pi over 3, that would be 13 pi over 3. Okay, now I left myself all this nice space so I could reduce if I needed to. But none of these actually reduce, so that wasn't really necessary this time. So I'm just going to copy these down. So I've got 4 pi over 3, 7 pi over 3, 10 pi over 3, and 13 pi over 3. Okay, so those are my 5 key values on the right. This will be one period of the tangent function on the right. In fact, well, I was thinking about drawing it, but these numbers are in the way. So let me keep going and find the values going to the left. Alright, so going to the left, I'm going to subtract 3 pi over 3. So 1 minus 3 is negative 2. So I would have negative 2 pi over 3. If I subtract 3 again, that's going to be negative 5 pi over 3. If I subtract 3 again, that's going to be negative 8 pi over 3. And if I subtract 3 again, that's going to be negative 11 pi over 3. And again, none of these reduce, so I did not need to leave myself the space that I usually leave myself. But hey, better safe than sorry, man. I remain unapologetic. Okay, so these are the 9 values I'm going to use to do my graph. So now I can erase all this, which may prove to be in the way. Let us never forget that this pi over 3 is the middle. So as I mentioned before, my tangent function will begin and end right there. Okay, so I know I'm going to, so there's no vertical shift. So this tangent function is going to be right on the x-axis. So it's going to begin at the phase shift, and so 4 positions over will be the end. So it's going to begin and end on the midline. And there should be an asymptote right in the middle. So this 7 pi over 3 is going to be a vertical asymptote. Okay, so that's one period will be over there. I will have another period if I come over here and put an asymptote again right in the middle. Okay, now the a value is 1. And I need the a value, and I need a y-axis. So I need to draw my y-axis, which is always at 0. Do not put your y-axis at pi over 3. Alright, the y-axis does not belong there. It has to be at 0. So the y-axis, I'm noticing that this is positive and this is negative. So I know that the y-axis is going to be between these two values somewhere. So I'm going to put my y-axis right here. I'm going to go ahead and label my a value, okay, which is going to be at 1, and then at negative 1, of course. And in addition to that, I'm going to put these little dotted lines at the a value. Even though the tangent function has no amplitude, because it just keeps on going forever, this a value will still be part of my graph. So I'm going to mark it. Alright, and now you'll see how this works. Because the tangent function is always increasing, so it's going to rise from here as it approaches the asymptote. However, when it gets halfway over at this mark right here, it should be at the a value. So I'm going to make sure I hit that as I go by. Okay, so that's going to look like that. And then I'm going to start over from below, and I'm going to rise my way to this. But as I pass by the halfway point, there should be a point at the a value. So it's going to rise as it goes, but I'm going to make sure that I hit that point. Okay, nothing special is happening at the y-axis. Okay, and now I'm going to continue to increase my way towards this asymptote, but at the halfway mark, it should be at the a value. So again, I'm going to make sure that happens. And one more time, I always have to be increasing with my tangent function, but again, at the halfway mark, it should be at that a value. So it's going to be looking something like this. Okay, so that is it. That is a completed graph for my tangent function. The only thing missing is I need an equation for my asymptotes. Okay, so I usually like to pick my first positive asymptote that I graph as sort of my starting position. So I see that that is going to be 7 pi over 3. Asymptotes are always x equals something, alright, because of vertical lines. So I'm going to start off by saying x equals 7 pi over 3. Okay, now I'm going to either add a full period or a half of a period for these asymptotes. When it comes to the tangent function, I notice that these asymptotes are a full period apart. I have to go 4 whole spaces from one asymptote to the next. Okay, so I'm adding a full period. Remember the period is 4 pi. So I would need to take this starting asymptote and add a full period of 4 pi. But then I'm going to add the variable n as a multiplier to represent all of the infinitely many asymptotes at which I will arrive if I kept on adding another 4 pi and another 4 pi and another 4 pi. And because n can be an integer, alright, if we label n as an integer, then it is also negative. Integers could be -1, -2, -3. And that will get me to, for example, this negative asymptote, and all the other ones going to the left. So this would be a good equation for all of the asymptotes. Okay, that is it for number 17. I know this video is already long, but I just have one more equation I would like to graph, so I'm going to go ahead and squeeze it in. First, I need to rewrite this equation. I see a b value and a potential phase shift. The b value must come outside of the parentheses. Got to factor it out. So that's going to leave x minus something. Now, to find out what goes here, I need to take this and divide it by the b value that I just took out. So in that case, that's just going to be pi over 2. This divided by that. Alright, so I'm just going to put all of that in parentheses now. So I've got my cosecant. Alright, y equals all of that, and then the plus 1. Let's talk about the period. The cosecant is the reciprocal of the sine function, so that's good to keep in mind. So just like the normal period for the sine function is 2 pi, that's going to be the same for cosecant. So the period of this function is going to be the normal period divided by the b value, which is 2. So these will cancel out, so the period is going to be pi. Now the phase shift can be found right here. Okay, it's the h value. Notice the sign change that's about to happen. This negative pi over 2 means that the phase shift is plus pi over 2, meaning to the right. We will do the asymptotes at the end once we have the graph. Oh yeah, there is a vertical shift that we will have to deal with, so watch out for this k value, which represents a vertical shift. Now, let's go ahead and get the x-axis going. Alright, saying there's going to be a vertical shift, so I'm going to leave myself a little bit of extra space toward the top. Okay, so here is my x-axis. It's a little wavy, but good enough. I always start at the phase shift. So because my phase shift is pi over 2 to the right, then I'm going to put my first mark here, okay, but I'm going to call it pi over 2. Alright, because that's the phase shift. Now I am going to put 4 more marks over, so here I go. 1, 2, 3, 4. Alright, that'll give me a full period of this function. I need to label them. So in order to label these, I need to add a quarter of a period. Okay, so my period is pi. That means a quarter period is going to be pi over 4. Alright, a fourth of pi. So I need to take this phase shift and add a quarter period. Each one of these marks is 1/4 of a period further to the right. So I'm going to add a quarter period. I'm going to add pi over 4, which will give me the next value and the next value and the next value. And now, of course, to do that, I need like denominators. So I would have to multiply the numerator and denominator here by 2. So this phase shift could be thought of as 2 pi over 4. And so now here I am adding 1 pi over 4. So that's going to make this 3 pi over 4. Now if I continue that process of adding pi over 4, this would be 4 pi over 4 and 5 pi over 4 and 6 pi over 4. Okay, now I have left myself space to reduce, so that's what I'm going to do. 3 pi over 4 does not reduce, so I'm just going to write that down. 4 pi over 4 is just pi. 5 pi over 4 does not reduce, but 6 pi over 4 reduces to 3 pi over 2. Now, I need to know where the y-axis goes. The y-axis will always go at 0, but I don't see 0 here, and I don't see any negative numbers. So what I need to do is continue marking off the x-axis to the left until I either get to 0 or until I get to a negative number, because that will tell me where the y-axis is. So I'm going to put a couple more marks to the left, and I will hope that that will be sufficient. So a moment ago I was adding 1 pi over 4. As I go to the left, I'm going to be subtracting. So if this is 2 pi over 4, this will be 1 pi over 4. Hold on. Just to be consistent, I'm going to use this pinkish red color. So this would be 1 pi over 4. And then if I subtract it again, this would be 0 pi over 4. So this 0 tells me where the y-axis goes. It will actually go right here on the end. Okay, so I will go ahead and put this pi over 4 right here in light gray, so you can see what it is, but it is not one of my 5 key values that I will use to graph this function. So don't get it confused with the 5 key values. And of course, like I said, the y-axis will go here at 0. So I'm going to erase these reddish pink numbers now. There's always a debate in my class over whether that's red or pink. It's not really a big debate. My students seem to all agree that it's red, but I insist that it's pink. So the debate is just me versus the students. Anyway, here's the y-axis. Okay, what now? Vertical shift. There's a vertical shift of +1. So I need to make that happen. So I'm going to put a mark here. That's going to be 1. Now, amplitude. Cosecant, as you'll see, has no amplitude because it goes up and down forever. But because cosecant is the reciprocal of the sine function, the first thing I'm going to do is graph the sine function. And sine function does have an amplitude, and that amplitude will be 2. So because of that, I need to be prepared to go up 2 from this midline. In fact, let me go ahead and get this dotted line in here. Alright, this will be my midline. Okay, now if I go up 2 from the midline, okay, so this will be 2 and 3. And if I go down 2 from the midline, that will be 0 and -1. And I'm going to put some dotted lines at those amplitudes as well to help me make a more accurate sketch in a moment. Okay, it is time to graph the sine function first. Now, this is not the actual graph, so when I graph my sine function, I'm going to do it very lightly. The sine function starts at the midline, so looking at my 5 critical values, this is the beginning of the period, and the sine function starts at the midline. And then it goes up to its high mark, okay, after a quarter of a period, and then after another quarter of a period it falls back to the midline, and then it falls to its lowest value, and then it ends up back on the midline again. So I'm just going to very lightly sketch the sine function. Okay, this is not the actual graph, so I cannot darken it in. Okay, I'm just going to very lightly sketch it. Okay, so there is a light sketch of my sine function. Now, because the sine function is in the denominator of the cosecant function, before we did this vertical shift, this midline was the x-axis. So everywhere the sine function was at the midline, it was 0. We were dividing by 0. That's why you're going to have an asymptote everywhere the sine function touches the midline. Even though there's been a shift now, the asymptotes are just shifting along with everything else. Okay, so the bottom line is everywhere the sine curve touches the midline, there's going to be a vertical asymptote. So there should be a vertical asymptote here at pi over 2. So I'm going to just put that in as a dotted line. And then it touches again here at pi, so there should be a vertical line there as well. Vertical asymptote. And it touches again here at 3 pi over 2. So another vertical asymptote here at 3 pi over 2. Okay, so I know that the highs and lows of my sine function coincide, they intersect with the cosecant function. So this high point is going to be a point on the cosecant function, and this low point will be a point on the cosecant function. From there, I'm going to just face away from the midline and go towards these asymptotes. So I'm going to reach toward the asymptotes on the left and the right, like this. And I'll do the same thing down here, just reaching towards these asymptotes as I go away from the midline. And that is it. So these blue curves represent the graph of my cosecant function. The only thing missing is I need equations of the asymptotes. I need an expression that represents them all. Vertical lines are always x equals something, so don't forget that. I usually choose my first positive asymptote. Well, they're all positive, so I'm just going to pick pi over 2 as my starting asymptote. So I will put pi over 2. Now, I'm going to add however far I have to go to get to the next asymptote. Is it a full period or is it a half of a period? Well, notice between the asymptotes there are only 2 spaces apart. That's half of a period. Okay, so let's see. So full period was pi. So half of a period is pi over 2. So to get to the next asymptote, I must be adding pi over 2. which makes sense because pi over 2 plus pi over 2 would be pi. And okay, and see there's an asymptote there. But I don't want to just get an expression for one asymptote. I want all the asymptotes. So I'm going to put a multiplier on here. I'm going to put an n. So I'm going to, instead of saying plus pi over 2, I'm going to say plus n pi over 2. Alright, and I'm going to let it be known that n is an integer. Alright, this is an integer, meaning it could be a positive number like 1, 2, or 3, or a negative number like -1, -2, or -3, or 0. So depending on the value of n, this equation will give me any and all of the asymptotes going to the right and to the left. So that's it. And that was a very long video, but I hope you found it to be helpful. And I will see you on the next video.